My name is Paul Stone. I'm a security consultant. I work for Context Information Security in the UK. And I'm going to be talking to you this afternoon about clickjacking. So this is a quick summary of what's coming up. First of all, I'm going to give a quick introduction to clickjacking as it stands today, just for people who maybe don't know that much about it. Then I'm going to show you 4 new cross-browser attack techniques that take clickjacking and build on it to do some exciting new things. Then I'm going to show you a tool that I've written that allows you to experiment with these techniques and try them out, see how they work. And at the end, if I have time, I'm going to show you some browser-specific exploits that I found during the course of this research. But before all that, I'm going to show you this. Okay, so this is a puzzle game. It doesn't look very good because I wrote it. It's basically a sliding block puzzle game. You drag the blocks around. The idea is to try and get the red square out of this and onto the grey square. I don't actually know how to complete this. Apparently, it takes a minimum of 81 moves to complete, and that's if you know how to do it. So I'm probably not going to finish that now. But anyway, so this is a web game. Perhaps you're just playing it online. Looks fairly innocent. But let's take a look at what's going on in the background. All this information has been sent from my web browser to a remote attacker. Each of these frames here has some fairly sensitive information in. This is a document from Google Documents. This is the page it's stolen from. This is a Gmail inbox. This is the main version of Gmail. This is the Google Gadget version of Gmail. As you can see, the pages don't have any styling on, but the information is there. So there's various other things there as well. So how did that happen? Let's go back to this, and let's go back to the beginning and talk about the basics of clickjacking. Now, clickjacking relies on iframes. Iframes allow you to take one site and frame it in another site, so they're on the same page. Now, there's a few misconceptions about how iframes work. So I'll just go over them now. First of all, any site can frame any other site, even if they're not on the same domain. Secondly, even if the site being framed is HTTPS, that still works, even if the outer site isn't HTTPS. Thirdly, if you're logged into a site, then all your cookies will be sent along with the request in the iframe, so that you'll be logged into that site inside the iframe. So that's what clickjacking uses. You might think that because the 2 pages, 2 different sites from the same page, that an attacker can just read what's in that frame. But that's not the case. This is what the outer page sees in reality. And the reason for that is because the browser's same origin policy prevents any JavaScript access inside the iframe because it's from a different domain. So these are some errors up here that would happen if you tried to access the JavaScript. So clickjacking is a way to get around this and still do some bad stuff with what's inside the frame. So I'm going to quickly run through how clickjacking tech is set up. First of all, we have a target site. Twitter obviously was already targeted in a clickjacking attack a while back. So this is how they did it. First of all, we take the site that we want to we want to get the user to do something bad on the site, basically. So in this case, we want to get the user to click the tweet button and send this message to all their friends on Twitter without realizing what's happening. So first of all, we frame the site, and this page is called inner.html. Then we decide what area of the page we want them to click. In this case, it's the tweet button. Secondly, the second step is to use CSS to move the iframe up and to the left so that the target we want to click is on the top left-hand side of the page. The last step is to take that page and include it in another iframe, and then lets us crop the page so that only the particular target that we want the user to click on is visible. So in this case, it's the tweet button, and there are 3 different ways this can be done. First is to show the target fully visible, and This is called UI redressing. The way this could be used is, for example, using that button in another context. So persuading the user to click on it. For example, if it was a submit button, they may think they were submitting another form rather than the site that's being attacked. The second thing we can do is we can actually make the iframe invisible, and we can layer it over other content on the page. So in this case, we have a button that says something else, and we can layer the button on top of that and get these to click that. What will actually happen is that they'll click on the button in the framed page instead of what's underneath it. The third thing we can do is use JavaScript to make the iframe invisible and very small and make it follow the mouse cursor, so that wherever the user moves their mouse, when they click, they'll be clicking on the target no matter what happens. Okay, so to fully understand why clickjacking is important, we need to compare it to other browser attacks. So some other attacks that take place in the browser are cross-site scripting and cross-site request forgery. Just for fun, I decided to Google these and see how many results I got for each. As you can see, cross-site scripting is by far the most popular in terms of Google results, and the other two have fewer results, with clickjacking had the least. If we, however, look at how long these attacks have been around, these are rough estimates, we can see that cross-site scripting, cross-site request forgery are fairly old attacks. Clickjacking is fairly new. Now, what we can do is take the number of results, divide it by the number of years, and we end up with a completely meaningless number we can put on a graph. Pretty much the only thing this shows is that although clickjacking has only been around a couple of years, there's a lot of interest in it, a lot of buzz, possibly because it has a much scarier sounding name than the other two. So I'm just going to quickly recap the other two, these attacks. First of all, cross-site scripting lets you inject JavaScript into a web application. If we can do this, you can run any JavaScript code on the site. It's pretty powerful, even though it's a fairly common, well-known attack. With cross-site scripting, we can read the user data, we can execute commands on the website, we can inject data, and so on. It doesn't require much user interaction. Cross-site request forgery is less powerful than cross-site scripting. We can send requests into a web application, perhaps by following a link from a website, and we can trick the web application into honoring that request to do something bad. Now, cross-site request forgery, with this attack, we can only put information into an application. We can't read back any results. So in this case, this My Bank site, perhaps we could transfer some money from one account to another, but we couldn't read back the page to see if it worked or not, at least not directly. Cross-site request forgery can be beaten and stopped by having a random token with each request. So in this case, you can see at the bottom, we have a random token that the website knows, but a malicious attacker wouldn't know, and therefore each request can be checked to make sure that it originated from the site and not from somewhere else. Clickjacking. The basics of the attack is it's getting someone to click on a button or something inside an iframe to do bad stuff. The other thing, when clickjacking was first announced, was the flash vulnerability that allowed you to access a user's webcam and microphone. That's been fixed now, but most sites are still vulnerable to clickjacking. So clickjacking lets you bypass cross-site request forgery protection. Because the attacker doesn't know the cross-site request forgery token, we say, well, we can get around that by just getting the user to interact directly with the form. The problem with clickjacking is that we can only input clicks into an application. Now, if you think about it, there's only so much you can do just by clicking on things in a website. Perhaps you could click on delete all or something like that, but with clicking alone, there's not all that much you can do. So to make clickjacking more powerful, current attacks that have happened use clickjacking with cross-site request forgery. So this request you see on the page is what happens when you when you update your status on Twitter. So in this line at the bottom here, we have the random token and we have the status. If that random token isn't there, then the update won't happen. So a clickjacking attack, to be successful, we need to get some data into a particular form. Now, Twitter makes that easy because we can have a link that includes the status. So in this example, it's hello. If we open up that link in a browser, hello will already be in the input field so that we can then just require one click to update your status. Now, most sites implement cross-site request forgery protection, but quite a lot of them do it in a way that makes clickjacking pretty easy. So this is a screenshot from Bugzilla, which is issue tracking software that Mozilla use for Firefox. Also, WebKit uses it as well. This is what happens if it detects a cross-site request forgery attack. But actually what happens is we can click this button at the bottom to say, yes, go ahead, do these changes. So although it prevents cross-site request forgery, all that would be needed for a successful clickjacking attack is just to click on that button. So one of the problems with clickjacking, one of the things that makes it fairly tricky to carry out, is that we need to know the exact position on the page of the target. So you remember the Twitter example from earlier. In order to target this button and do the positioning, we need to know the exact number of pixels from the left and from the top in order to target it. But what happens if the page changes and the target moves? Well, if this is an attack that someone has prepared, if the page changes when the user actually does it, then they'll click on the wrong part of the page. So how can we get around this? One method which I've come up with is to use fragment positioning. Now, I'll just go through this. People who are familiar with HTML, probably this will be familiar to them. So in the source of a page, we can have this anchor tag and give it a name. If we then visit a page and have this name at the end of the URL, the browser will scroll down to make that section visible. So we can use this same method to position a target in an iframe for a clickjacking attack without knowing exactly where it is on the page. Now, although lots of web pages don't use this a name tag, most web pages have elements with ID attributes, and we can also use ID attributes to scroll down to a particular element. So this is an example from the Google accounts page. Now, each of those little boxes you see is an element that has an ID. So we can use this method to target any of these elements without necessarily knowing where they are on the page. So although we're just used to seeing a browser scroll vertically to make a particular element visible, if we do this in a very small iframe, then the browser will scroll both horizontally and vertically to make the target visible. I'll just quickly show you how that works. So this is a page with some randomly moving buttons, and using normal positioning methods, we wouldn't know where to pixel positions of any of these elements. But if we include the ID of each of these elements in the URL, then the iframe will scroll to the correct one, like so. Okay. So everything I've shown you so far is pretty much what people know about clickjacking at the moment. Now, one of the problems, as I've said before, is that we're relying on cross-site request forgery to get data into a form and then use a click to submit it. But what if we can't use that method to get data into a form? How else can we get that data into the form just by using the clickjacking method? Well, one way is to use drag and drop. Now, every modern browser supports a drag and drop API. Drag and drop is similar to copy and paste. It lets you transfer data from one place to another. With drag and drop, you're using the mouse to do that. So you hold down the mouse button, move the mouse, and release it somewhere, and the data is dropped into a particular element. Now, the thing with drag and drop is it doesn't have the same origin policy that prevents JavaScript from accessing. It prevents JavaScript on one site from accessing content on another site. So the user can actually drag data from one site to another, and because user interaction is required, browsers don't prevent this. So here's just some code that shows how we can use a drag and drop API in a browser. So what this says is, when I start to drag this element, associate this data with it, some text, And when it's dropped, that text will be entered into a text field or onto the site. So I'll just show you that quickly. So this element uses the drag and drop API, and each time I drag it, it will associate some text with the element. This green area here is a page from another domain. And as you can see, each time I drag, it's putting different data into here. So this would be really useful if we can combine this with clickjacking and get the user to input data into a form. So how can we do this? First of all, we use the same hidden iframe technique that I showed you before. We have the little iframe following the mouse cursor. Secondly, we need to get the user to drag something. Now, there's many ways we can do this. It could be dragging a scroll bar. It could be some sort of game, like the sliding puzzle game I showed you earlier. Now, when the user starts to drag the particular element, we set some data with it. So this is the data the attacker wants to inject into the other side. Now, as they're starting to drag, the iframe will follow the mouse cursor. And then when the user releases the mouse button, the text will be entered into that field inside the iframe. Then we need another click to submit the form, and the attack's complete. So I'm just going to show you this demo here, just to show you how that works. So this is a little game which people might be tempted to try out. So what we'll do is we'll start to drag this frog over here. Now you can see that little square that's appeared. That's actually an iframe. Actually, I'm just going to show you. Oops, that one there. I'll just show the page that's being targeted here. This is a generic social networking fake site. So we can send status updates like this, and so on. So we want to basically get the user to enter some text in here, click the update, and that will be sent to all their friends. So we're dragging. Now the iframe has got the text field on that other page under the cursor. So when we release the mouse button, the iframe is now positioned so it's over the update button. So when we click the on button, splat, and here is what's happened. That text has been injected there. So in this case, the iframe was visible, but in a real attack, it would be completely invisible. The user would have no idea what's going on. Okay, so that's text field injection. Obviously, the downside to it compared to normal clickjacking is it actually needs the user to drag something. And that's a bit harder than just getting to click on stuff. Clicking is what most people do on the web most of the time. In order to get them to drag something around, we need to engage the user with it a bit more. So there'll be some more social engineering required there to carry out a successful attack. But on the other hand, it does completely bypass cross-site request forwardery. We're not relying on partial cross-site request forwardery to get data into a form and then get the user to click the button. We're doing everything just by using iframes and the user interaction. So there's many things this could be used for. For example, with webmail, you could target the to field, the body field, and then you could send fake emails from a user's account. You could also edit documents in some sort of authenticated document editing system and place data in there without the user realizing it. This technique works in all the browsers. It's completely cross-browser. Okay, so that was content injection, and that bypasses cross-site request forwardery. But we can actually do even better than that. And we can get data out of an iframe. So how does that work? Well, we actually reverse the drag and drop technique that I showed you. Instead of dragging data into an iframe from the attacker site, we get the user to drag content out of an iframe and onto the attacker site. So again, with the drag and drop API, we can use the on-drop event to get any data that's dropped onto the page. So what kind of stuff could we drag out of a page? Well, links and images are draggable by default. And when it's dropped onto a page, they get converted into the equivalent URL. So links can sometimes contain sensitive information. They might contain user ID. They might contain a secret hash, for example. In this case here, this is the ID of a Google document. If we could somehow get that and drag it out of a page, that's pretty good. But links aren't all that interesting. What we really want is the content of a page. So, text selections are draggable. What I mean by that is if you select some text on a page in a web browser, you can then drag that out of the browser onto another page. So somehow we need to be able to get the user to first select some text on a page and then drag it out. And that would work, but it sounds pretty tricky. But it is possible. So here's how we do it. This is a document which, let's say we know the URL of it, but we don't know the content. So if the user is authenticated and has access to the document, we might want to try and steal the content of this from the user. So again, we use the hidden iframe concept. And first of all, we place in the hidden iframe, we target the top of the page. Then the user starts to drag. So again, for example, at the beginning I showed you the sliding block puzzle. So the first time we start to drag a piece, that starts to create a selection. And obviously, this page is quite long, and we don't want the user to have to drag all the way to the bottom of the document. But what we can do is as soon as the user has held down the mouse button, we can then position the iframe, the document inside the iframe, so that the bottom of the document is targeted. What that means is that as soon as the user has moved the mouse, even by a small amount, with the mouse button held down, the entire document has been selected. So then the user finishes that drag, and then we need to get the user to drag again. And so in this case, we would target position C. At this point, all the text on the page would be selected. And then we get the user to drag. Again, this would be in the example at the beginning, it would be moving the puzzle piece for the second time, and it would drag the content from the iframe and drop it onto the attacker's page. Now, I'm going to show you an example of this at the end to see exactly how that works when I show you the clickjacking tool. Now, the drag and drop API in web browsers lets you transfer plain text from one place to another. Now, in the case of a document, the text content is valuable information. But if we think about authenticated web pages, if we think about the actual HTML source of that, there can often be some fairly interesting and sensitive data in there. So, for example, one example is cross-site request forgery tokens. So on a page that has cross-site request forgery protection, there will be a form that has normally a hidden field that will have this random token in. Now, if we can steal that token, then the site suddenly becomes vulnerable to cross-site request forgery. Each request that we send in, we can include this token and perform an automated attack. Now, the way sites implement cross-site request forgery vary. Sometimes each token is valid only once, but sometimes tokens are valid either for an entire session or maybe for a limited amount of time, say 10 minutes. So to get the source of a page, we can use the same method I showed you before, but instead of using the drag and drop API in the browsers, we can use an editable HTML area when the user drops the text onto there. So every web browser has a rich text editor built in, and it's the kind of thing that you use when you're in webmail editors and so on. You can make text bold, you can make it italic, and there you're actually editing HTML. Now what happens is when you select some text on a web page and drop it onto there, it will actually copy that HTML and recreate it inside that area. So again, we can drag from one page, one domain, to an editable area on another domain, and all the source there will be copied across. This is called design mode or content editable. That's how it works. So content extraction. This is the second technique. So again, a bit more user interaction is required to make this work. So instead of just the one drag we're using to inject text into a form, we need two drags. So the first drag will select the text, the second will drag it out of the page. On the other hand, the size of the page doesn't matter. So we can select the entire text of a page, even with just a very small mouse movement. One interesting way this could be used is for internet reconnaissance. So, for example, we may know the URL of a page. It may be in a private intranet, but we don't know the content of it. Now, if we can guess some positions on the page, we can guess the top of the page and roughly where the bottom of the page is, and we can then potentially get at that data by dragging it out. So again, this technique works in all the latest browsers. In WebKit-based browsers, when we're copying the HTML out of a page, the hidden form fields and script tags don't get copied across. So that's a bit of a limitation with this technique. So we can't use it in this case to steal cross-site request forgery tokens, at least not in Safari and Chrome. Again, I'll show you at the end a demo of how that works. So on to technique number 3. Now, if you think back to the text injection, that required a drag and drop to work. Now, that's okay, but the question is, can we get a user to do that? And also, if we want to fill in a form with many fields, for example, an address field on an online shopping site, we need to get the user to do a drag for each of those, and that's not likely to happen. However, I've been looking at the Java drag and drop API. Now, Java has its own drag and drop API, separate from the one in web browsers. The API is a bit more advanced than in web browsers, and there are various interesting things that you can do with it. So, for example, there is a class called mouse drag gesture recognizer. Now, in a Java applet, we can actually override that to change the behavior of how a drag and drop operation works. So what we can do is, instead of saying, okay, a drag and drop consists of the user holding down the mouse button, moving the mouse a certain number of pixels, and then removing their mouse, we can actually say, okay, when the user holds down the mouse button, then we're going to start a drag and drop them. And because we can do that, we can drag text from a Java applet using just a click instead of a drag. So we're back to the same user interaction as with traditional clickjacking. We're just using a single click to do something interesting. In this case, injecting text into a field. We can actually go even further with the Java drag and drop API. And we can say, okay, instead of requiring the user to do anything with a Java applet, actually just start a drag and drop event right now. So JavaScript on a malicious web page could use a hidden Java applet to force the user to enter text into form fields. And the way this works is that the web page would say, okay, start a drag and drop with this text, and wherever the user's mouse cursor is, the text will be dropped onto that area. So if it's over a text field on top inside an iframe, inside a hidden iframe, then the text will be entered into there. So I'm just going to show you how that works. This is pretty fun. Okay, so in this case we have a visible iframe, just so we can see what's going on. In a real clickjacking attack, obviously this would be hidden and possibly following the user's mouse cursor. Now you see this little grey square here. This is actually a Java applet. And when I click on it, it will start a drag and drop operation, or at least when I hold down the mouse button. So I hold down the mouse button, and it's moved out of the way. And although the mouse cursor hasn't changed, normally it would change to have a little plus sign to show that a drag and drop was going on. We can actually override that with Java API. We can say, show the default mouse cursor instead of a drag and drop cursor, and the user has even less idea of what's going on. So now I'm going to release the mouse button, and the text is entered into that field. So I can just carry on like that and fill in an entire form without using cross-site request forgery, without using drag and drop, which is pretty cool. Second thing I'm going to show you is the forced drag and drop. So instead of getting the user to click, the script on the page is just going to say, do a drag and drop every few milliseconds. So when I click on the Start button, that's going to happen. So here we go, just moving the mouse around, and it's entering text there. Again, this is visible, but it could be in a hidden iframe, and you'd be filling in fields in a form on another site. Actually, in Firefox, this does go a bit crazy, and it will work up there as well. Yeah, that's... okay. So that technique I just showed you, it's called form spraying. So instead of requiring a click for each field we want to fill in, we can actually just fill in lots of fields in one go. Now, the details of this vary between various browsers. In some browsers, you have to move the mouse between each drop. For example, that's the case with Chrome. So actually carrying out this attack may be a little tricky, but it's definitely possible. This also does work on Macs with the default Java runtime there, but it doesn't work on Linux. On Linux, you actually still have to do a real drag and drop moving the mouse for this to work. Okay, so that was techniques for injecting data into a web page and extracting data from a web page. So all of those, like normal clickjacking, require user interaction to work. I'm going to show you something a little different here, and this is something which I actually discovered during the course of preparing this presentation. And it allows us to get some information out of a frame automatically. Now, you remember at the start of the presentation, I said that the same origin policy prevents one site from accessing the content of a framed page. Now, that's not entirely true. So, if you think back to near the start of the presentation, I mentioned the fragment positioning method. That was using IDs in a page and using the fragment identifier at the end of the URL to make the iframe scroll to a particular element without knowing exactly where it was on the page. Now, clickjacking uses nested iframes. So we've got an inner iframe that has a particular site in, and then we have the outer iframe that's cropping it and positioning it on a page. Now, with the fragment positioning, what happens when you load a URL with a fragment on it is that the browser will scroll the iframe to make that particular element visible. Now, we've got the two iframes, and what the browser actually does is scroll the outer iframe, and that's controlled by the attacker. And because for that reason, we can actually read back the scroll position of the iframe and detect the position of a particular element on a web page. So this is how it's done. We load a page in the iframe. We make it very small. We navigate to a particular URL and include a fragment at the end of an ID that we know might be in the page. And we can then read the scroll position of the iframe to tell whether or not it's in the page and also the position of it on the page. Now, what use is this actually? There's been various research to determine from a browser whether or not the user is logged into a particular site. This is useful for something like clickjacking because it requires user interaction. Now, let's say someone was trying to target a user's webmail account. The user might use Gmail, they might use Yahoo, they might use Hotmail. Now, because a clickjacking attack requires user interaction, we don't want to target a site that they're not logged into, that they're not using. So if we can tell whether they're logged into a particular site, that could potentially be very useful. There's various current techniques that try and do this using methods such as seeing if a particular page is cached in the browser, and also things like trying to load an authenticated image. If you're authenticated, the image will load. If it's not, it won't load. Now, those techniques, they do work, but it's very different how it works for each site. This method can be used in a very large range of sites because nearly every web page has an ID in it. So these are the kind of things we can do with this. At the most basic, we can do login detection. So we can tell whether a user is logged on to a particular web application. So we can say, okay, let's load an authenticator page in the iframe. And if you're logged in, that page will load. If you're not, it will probably redirect to a login page. So we can pick an ID on the page, and on the authenticator page, and we can say, is this ID present in the page? And if it is, then the user's logged in. If it's not, then they're not. Now, we're not just checking, with this technique, we can tell not only that a particular element with a particular ID is on a page, we can also tell its position on the page, because we can read the scroll position. So we can do more interesting things as well. So, for example, if there's a footer on the page that has an ID, we can load a page and tell how far down the page that footer is. So if the page is variable length, we can tell things like how many emails are in the user's inbox and various things. So there are many applications to this beyond clickjacking. I'm sure people will come up with interesting things that can be done with this. I'll just quickly show you how that could work. Okay, so this is a page. This is copied. This is a copy of a page, an offline copy of the Gmail inbox as would appear in a Google gadget. Now, there's various IDs on this page, and we can detect various things. So here we go. When I've loaded this page, you can see a little tiny iframe up here, and that's got that page in it. And by trying to navigate to particular IDs, it can tell various things. So, for example, there's an ID on the page called current label, and we could use that to detect if the user is logged in or not. Also, each message down here has an ID like this, so checkbox 0, checkbox 1, and we can actually detect how many emails are in the inbox. And here you can see it's also read the position of a particular ID that's at the bottom of a page. Oops. Okay, so that was some new clickjacking techniques. Perhaps the most important thing is how sites can protect against these attacks. So at the moment, there are two ways to protect a site from clickjacking. The first is to use something called X-frame options, and this was introduced by Microsoft in Internet Explorer 8, and various other browsers have implemented this as well. And what this says is it's an HTTP header, and if a site sets this header, it basically says, do not allow my site to be included in an iframe. And you can see here, this is what happens in Internet Explorer if you try and load a site in an iframe that has this header set. Now, this is probably the best method to protect against clickjacking, but unfortunately, older browsers don't support this, and also Firefox doesn't yet support it. They're working on it, but it's not there yet. So to protect users who use those other browsers, we have to use JavaScript. Now, there's two main ways to use JavaScript to prevent clickjacking. The first is to use frame busting. What that is a site will say, if I'm framed, then break out of the frame, and it will replace the page that's framing it. The other thing you can do is, instead of trying to break out of the frame, is you can hide a site can hide its own content. So if it detects it's being framed, it can prevent the user interacting with it. So the user can't click any buttons, and nothing bad can happen. You can see here, this is Twitter and Facebook. Both these sites have slightly different clickjacking protection. What Facebook does is it will put a semi-transparent overlay over a page if it's being framed, and when you click on that, it will try and frame bust. Twitter, on the other hand, it tries to frame bust all the time. If that doesn't work, there are various ways to prevent frame busting. It will just hide its content. Unfortunately, JavaScript protection isn't 100% effective. One method to prevent a site from frame busting is to use HTTP redirects to stop a page from loading, from busting out. This page tells you how to do that. And there's also various browser-specific methods, I suppose really browser vulnerabilities, that prevent a site from frame busting. In Firefox, we can actually disable JavaScript in an iframe. So any site that uses JavaScript to protect itself from JavaScript, uses JavaScript to protect itself from clickjacking, that will fail in this case. The other thing you can do in Firefox is you can, in an iframe, you can load up a page and put view source in front of the URL. That will give you the same thing as what happened as when you view the source of a page, only it's inside an iframe. So we could use the content extraction method to get at that. In Internet Explorer, you can actually load up a site in design mode. What that means is we can put an iframe into editable mode, so any HTML that's in there you can edit. And then we can load another site in there, and the iframe will still be in design mode. So although you can't interact with the site, all the JavaScript will be disabled, so any clickjacking protection won't work. And although you can't submit forms, again, we could use content extraction to get at that data. So at the moment, not many sites have implemented clickjacking protection, although a lot of the high-profile sites that have suffered clickjacking attacks have actually put in some protection. Unfortunately, most of those sites are still vulnerable in one way or another. Many of the large sites have mobile versions of the main site. So, for example, Twitter has a mobile site, and it doesn't share the same code, so it doesn't have the same clickjacking protection that perhaps the main site does. And also, various sites have widgets or gadgets, and these are things that can be included in frames. So, for example, on the Google has a page that lets you have various widgets on your homepage and so on. Now, each of those are in an iframe, so they can't actually use clickjacking protection. They can't prevent themselves from being framed, so they're vulnerable. So this is Twitter. They've got two mobile sites. Neither of them have clickjacking protection. This is Facebook. Again, no protection on there, although I think they have now included protection there. And this is the Gmail gadget, which I showed you earlier. Again, this doesn't protect itself from being framed. For pen testers, if you're testing sites, you want to check if a site has put in clickjacking protection. You basically need to see if you can include it in an iframe. Now, CAT is a manual penetration testing tool that Context has released, and the latest version of that is being released today. It's available from my website. And one of the new features is that you can check to see if a particular page allows itself to be framed. So I'll just show you that quickly. This is the tool. And so this is a page. Again, it's offline. And we want to check if it's implements clickjacking protection. So I've now set up the browser so that any requests will go through the tool. Yep, that's appeared there. So then we can take a particular request and open this up. And here we can see the framed version and non-framed version, and we can see that something's happening here to prevent clickjacking. Okay, so now I'm going to show you the clickjacking tool that I've made, and it lets you take all the methods that I've shown you and try them out, see how they work. It's browser-based, and at the moment it works best in Firefox. I'll be updating it soon so that it works properly in other browsers. As I said, all the techniques that I've shown you work in every browser, but at the moment there's various little issues in the tool that prevent it from working completely well. So I'll just show you how it works in Firefox. So this is the clickjacking tool. In this area here, we have a site, and we can load any site into here. And it actually has an overlay so that we can move it around without interacting with the site. Along the side here, we have various tools, and I'll show you how these can be used. So again, we'll use this site that I showed you earlier and see how we can use the tool on this site to do various things. So first of all, I'm going to use the load URL tool to load that page into this frame. Now what we want to do is get the user to enter some text into this text field and then click the update button. So first of all, I use the enter text tool, and I'll drag this onto the text field. So this is where I want, this is the first target. And this is the text I want to enter. So this will use the Java drag and drop technique I showed you earlier. Second thing we want to do is click on the update button. There we go. And now we can replay this. So there's two ways we can replay it. First of all, there's a visible replay. So we've got the iframe, the targets following the mouse cursor, but we can actually see what's going on here. So we can see how this works. This is really useful if you, to get an idea of how these techniques work, so you can see what's going on in the background. So first of all, I click, then I click again, and there we go. That's put in there. We can also, let's put some different text in. We can also do an invisible replay, and so this is a bit more like what's happening in a real attack. Obviously, here we've got a blank page here. Wherever we click, it will actually still be clicking on those targets. In a real attack, obviously there'll be something to interact with here, so there'll be some sort of game or whatever. So again, click, click, and there we go, that's entered there. So I mentioned before about using fragment positioning. Now that can be useful if the content on a page is moving around and the targets are moving around. So I've got another version of this page that has this banner that appears and disappears randomly. So using the current targets are positioned just using pixels. So if we play this here, yeah, so that hasn't worked because this moved and we didn't know that was going to happen. So what we can do is use the IDs on the page, as I mentioned before. I'll just quickly show you the source of this page. So we can see here, this is the status field. So this has an ID of status, and we have the update button here that has an ID of update. So we can use a fragment positioning method to target those. So this tool makes it fairly easy to do that. We don't have to look at the source of the page. We can actually use this Get Fragments button here. So when I click that button, it removed the overlay, and I have to manually just select all and then drag this onto this little white square here. So yeah, you can see that there. It's detected all the IDs and the positions of the IDs on that page. So we've got the status here, we've got update, we've got the add one here, and we've got a footer down here. So I can say, okay, I want to use relative positioning to target these. So first of all, click on this status field, and I've got a marker here which I can drag. So this is saying I want to click at these coordinates relative to the position of the status field. And again, with the update button, I want to click at this position relative to the update button. So now if I replay this, oops, I didn't actually enter any text here. So I replay this, and the banner was there, and that worked. And again, if I replay it without the banner, it will still work. So although the page is moving around, you can still do accurate positioning. The final thing I'm going to show you with this tool is extracting the content. Now, I went over the technique earlier. I didn't show you any demos, so I can demonstrate it fairly well using this tool. So let's have a look at the source of this page again. I should just make that a bit bigger. So this site has protection against cross-site request forgery because it has this random token here. Now, what I've just shown you, injecting the text into the field, that's okay, but if we actually steal this random token, then we could potentially do many requests and do many updates on the user's page without any further user interaction. In this case, it's just updating a status on some social networking site, but there are many situations where if you can steal that token, you could potentially do bad things. For example, with a webmail account, potentially you could forward emails from a user's account to another email address by doing cross-site request forgery if we can get this token. Okay, so here's how we can do it. We're going to use the other two tools here. We've got a drag tool, and we can use this to do a drag from any point to any other point. So we're going to drag from here down to here. The hidden field that has the token is in the form around here somewhere. So when the user does this, when they drag, it will select this text here. And then I want to extract that selection. So I'm going to place it over some text that will be selected, for example, there. Now, when I replay this, so you can see this is the starting position. So I'm going to hold down the mouse button and do a drag. So you can see there, I just moved the mouse a little bit, but all that text was selected. And now I'm going to do a second drag, and that's going to extract the content. So you can see that this little red square here is that's the editable HTML field. Oh, that's timed out there. So if I drag this here onto there, that content has been stolen. So this little status box down here, if I click on this got.html, this is the HTML content that has been stolen. So this could have been sent to an attacker to do something bad. So this is what's visible, and this is the actual source that's been stolen. So you can see here, this is the token. So if the attacker can get hold of this, they can then do an automated cross-site request forgery attack and do all sorts of bad things. Okay, so that's everything for this tool. One other function is that you can actually export and import this data here. So this has all the positions and the IDs of the targets and so on. So if we wanted to build something like the sliding block puzzle I showed you at the beginning, we could use this data and incorporate it in some kind of game or whatever. It can also load data back in like that. Okay. So I think I'm doing okay for time. I'm just going to show you some things which I've discovered along the way of this research. So this is an Internet Explorer vulnerability that was fixed recently. What we can do here, unfortunately I haven't got a demo of this because the version of Internet Explorer on this laptop has been patched, obviously. But we can, using drag and drop and Java applet, we can actually drag HTML content into an iframe on a site. Now, you remember I said before in the various ways to prevent clickjacking protection from working, we can actually load any site into editable mode. And essentially what that means is that we're making a page on any domain editable, and we can edit the HTML, and we can drop HTML into there. So essentially we can do cross-site scripting against that site by dropping some HTML into there. And what this allowed you to do was pretty much do cross-site scripting on any site just by moving the mouse and using the force drag and drop from the Java applet. This is a Firefox vulnerability, which again I reported has been fixed. And again, it uses the Java drag and drop. And I do actually have a demo of this. So I'll show you what happens first of all. So here we go. I'm just going to click on this button. And there we go. So a command prompt popped up there. So I'll just show you how exactly what happened there. What I found was that with the forced drag and drop, if you drag a URL from a Java applet, the browser will actually load that URL automatically. And actually, that happens in Firefox and Internet Explorer. Now, in Firefox, the user interface is made up of special Chrome web pages that have their own URLs. And what this does is, the first time I click, it will load a page in this hidden, this window that's behind this window. So this has loaded up the Firefox About page in here. Now, what's special about Chrome pages is that any JavaScript that's executed on them will actually run with full privileges. So it can access your file system, it can do pretty much anything. So that was the first step. I've loaded this Chrome URL, which in itself isn't necessarily a bad thing. So somehow we need to get some JavaScript to execute on this. And one way we can do this is just by typing in a JavaScript URL. So if you type, that will execute. And actually what happens in here is when I, what happened here is it dropped in, uses a second drag and drop, forced drag and drop, to drop this JavaScript into the URL bar, which then executed. So I thought that was quite fun. Okay, so that is next generation clickjacking. So the techniques that I've showed you today go pretty much beyond what was originally possible. So we've got techniques for improving the precision of our targeting of elements on a page. We can inject arbitrary text into a web page, even if it's not vulnerable to any form of cross-site request forgery. And we can also go beyond cross-site request forgery. So we can actually extract content from a page, even if it's not vulnerable to cross-site scripting or anything like that. And we can also use the fragment position detection method to tell various things about what's inside an iframe. So that's it. Does anyone have any questions?
The clickjacking tool, is that publicly available?
Yeah, the clickjacking tool is available on our website, which was there. Yeah, so you can go and download that. It's a zip file, so you just have to extract it and you can run it in your browser. I'll be releasing updated versions of it to make it work better in other browsers and possibly include some other techniques. For example, the form spraying. At the moment, when you're injecting text into a field, you have to, it's one click per field. Hopefully, I'll be able to improve that so that we can have potentially one click, and then it will put text into lots of fields. So keep an eye on that on this page and for any updates that I do. Yeah.
Have you done a review of or collected statistics on the number of sites or top sites that have vulnerabilities against various clickjacking techniques?
I've not. So the question was, have I looked done any? Are there any numbers on popular websites that are vulnerable to these clickjacking techniques, particularly these new techniques? The answer is that I've only looked at a few sites. The mobile sites that I showed you earlier were sites that I just quickly looked at last week just to see what's possible. The answer is that lots of sites haven't implemented clickjacking protection, possibly because the kind of clickjacking that was possible before, like I said, you couldn't inject text into fields. So there's new things that are possible, and the vast majority of sites haven't put any sort of protection in. So yeah, there's probably lots of sites that are vulnerable to this kind of attack.
What would be the best method then to protect?
At the moment, there's no 100% method that will protect everyone. So my recommendation would be to include the X-Frame options header on all your sites. For users that don't have the newer browsers, still include the JavaScript protection. And hopefully browsers will sort out the minor issues that allow you to disable JavaScript and so on. And eventually all browsers will have the support for the X-frame options header. So at the moment, it's not ideal, but it should improve fairly rapidly.
So have you published anything that would expand on what you just said, like presenting more of those recommendations for protections against clickjacking?
No, there's the white paper, which I guess will be on your CDs, has a section on the defenses, which I talked about. But although I've introduced some new techniques here, the protections are pretty much the same. So if a site prevents itself from being framed, then it's not vulnerable to these attacks, and it's not vulnerable to the old clickjacking attacks. Okay, is that it? Great, thank you.